Swayam Prabha. Digital India. Educated India.
So again, I'm going to ask you the same question. Today, the topic is matter matters. Not matter matters. Matter matters. Got it? Okay. So we're going to understand experience materials. So I'm going to give a lecture. No. What am I going to do? Facilitate games. Huh? Okay? Huh? Only games you want, huh? Oh God, okay. All right. We'll start with the competition. Okay. So 1, 2, 3, 4, 5. I need 5 volunteers. Just raise your hand first. Okay. Come over here. Come. What's your name?
Pranav.
Pranav will choose the 5.
Pranav.
No, these people are not raising the hand.
All 3 of them.
No, they are not raising the hand. Go to only one per group.
One
Go
per
ahead.
group.
Sarvesh. Dhani. Anish. 1, 2, 3, 4. One among girls. He is going to choose. One among girls. No, but same group as Dhani, right? Yeah, sit down. He is going to choose one from other groups. There is one group there, one group here. Okay. Come over here. What is your name?
Anish.
Okay. So I'm going to give you an aluminum rod. Right? I'll tell you what to do. Just keep it till I tell you what the competition is. Huh? Ready? Okay. What's your name?
Anish.
Anish. Sarvesh. Dhwani. Sharanya. Sharon. Sharon. Okay. Sharon.
Pranav sir.
Pranav.
Thank you sir.
And Sarvesh. Thanks, Pranav.
Thank you, sir.
Yeah, poor guy. He was only used for. Yeah. So, what shall we ask him to do? Ask them to do? See, always your thinking is break. Okay, wait. Sarvesh. Anish. Who wants to support Anish? 1, 2, 3, 4, 5. You also support, huh?
Yeah, I support Anish.
No competitor. Wow. Who wants to support? Sarvesh. Again same. Oh, okay. Pranav. Hey, what is this here? This is partiality. At least one girl should say yes. No. Dhani. Oh, not bad. See, that's the spirit. Okay. And Sharon. Wow. You have so many words, huh? Wow. Okay. So, who do you think will win? Hey, look at her here. Look at her frame. She is going to break the rod. Okay. Among them, somebody who is strong will break the rod first. How can it be? They are smart, is it? Alpha. Dhwani is alpha, is it? Oh, okay. I didn't know that. Okay. Ready? Ready, steady. All you have to do is break. Wait. Ready, steady. 1, 3. Oh, oh God. Hey, what's happening here? Come on. Come on. Look at them. Give him a hand. Anish. Hey Pranav, you have to go to gym, yeah.
Sir, you are more also.
Hey, give up, huh? Give up, huh? Give up.
ಇಲ್ಲ sir.
Ah, illiya? Okay.
Sir, rod ದಾಡ. Life ದಾಡ.
Ayyo. Poor guy. Hey, don't do things that hurt you.
ಪರವಾದ bro.
Yeah, good, good. Fast, fast, fast. Yeah, he has broken
ಅರ್ಥ ಮಾಡ್ರಿ ನಾವು.
your friend has broken. Yeah, you raised the hand. I remember that. But I didn't realize that you will not be able to break.
Sir, slit range sir அந்த மாதிரி. Slit range. Cut.
You want to help him out? Not by coming here and breaking it, but tell him what to do.
Chemistry development.
There. Almost there. Almost there. Almost Pranav.
Sorry sir.
Yeah, Anish is going to help you as to how to break it. There. Yeah. Spirit, man. Spirit. Spirit. There. Give him a hand. Yeah. 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 Okay. Give them all a hand. Thank you. Thank you. Thank you. Okay. Now I have a set of questions. I have a set of questions. Ready? Chocolate questions? Oh my God, I forgot to bring chocolates. Where?
Observation sir.
No, that's not correct. I put it in a box, left it over there. Thanks, ma'am. How did he come? All right. All right. So, till chocolate comes, no chocolate questions. Okay. The first, so what is it that we see? That bigger transparent box was there, no? That you remember the one that was kept, I think, on the table or in the shelf. There is only one box there. Slide changing, eh? Oh, okay. Work out, ma? Okay. So that's we are going to tinkle around to find out and understand. Okay. What did we learn in the last class? One of those acronym. Found. Okay. So you know what it is, right? So we're going to use this for the challenge that happened over here. Okay. And before that, conditions. Number one condition is full cooperation, and the second one is highly interactive. Okay. If you have question, don't hesitate, ask. All right. But it's my time to ask questions. The first question, it has to do with observe. What did you observe? 1, 2. What did you observe when they were? Okay. 1, 2, 3, 4, 5, 6. Okay. Let's start with her. What did you observe?
They were bending it in the same spot again and again.
Okay.
Then-
Same spot. Wonderful. Okay. Did you do that?
Yeah, that's right.
Oh, very good.
So one thing I noticed was, Dhwani, you were holding the sticks in your
Yeah.
hand.
She will always
Dhwani's
give
stick-
long. She's a teacher, no?
Yes,
She
sir.
will give long.
Dhwani's stick did not bend, meaning it wasn't flexible, could easily break, whereas Pranav's stick easily bent no matter how many times.
How do you know it is flexible?
Because I saw
No,
his
no.
sticks.
Seeing is not
And
believing.
also hers was like bracket in the middle. His was cut.
Sit down.
Mine had a cut.
Wait. Somebody raise the hand here.
Vani and Sharon could bend the stick easily.
Easily, because they are strong. Correct. Yeah, okay.
the girls' sticks had like a bend in between and it was taped together.
No, nothing of that sort.
It
The
was
same
like-
rods.
No, sir, it had
They-
a black tape in between.
Why
and
is she
they
not
didn't-
believing that you are strong enough? What is this, yaar?
Because
Yeah.
I'm done.
Huh? Yeah, come on, yeah.
The rods were of varying thickness, as in the
Yeah, almost same thickness. It's the rod made for hangers, shirt hangers. Okay, out of that I had cut. Any other observation?
sir, there was a well.
Let's see if we had keen observation. Ah.
While distributing the sticks, you were particular about which stick you have to give to the girls and the boys. You
No,
started
yeah, I
giving
didn't even
it,
see it.
And then you didn't give
I didn't
Sarvesh.
even
You
see.
came back and gave to Sarvesh.
Yeah, but that is just so that one girl, one boy. Come on, yeah. One girl, one boy. But the fact of the matter is, I didn't see it. You observed it, no? Okay. I didn't see it, definitely. Okay. Okay. Any other observation? Come on, come on.
They use more strength and they did not use this.
Okay.
We used to this.
Okay. Why couldn't Pranav break it in one stroke? Sarvesh also weak? Hey, come on here. He's going to gym.
Oh, Pali, no, Ali, the round.
You poor guy. Yeah. Why did you do that? Okay. Any other observation? Come on. I think
Was it malleable?
you are capable of observation.
Was it malleable, sir? Pranav's stick.
No, you don't know malleable or not. Observation. Observation has to do with what they did.
Sarvesh required an external force to like break it. So
All of you needed external force. Good.
Stretching all broken at different points. I think one of them was.
You people have to observe better, yeah. Okay.
Sir, there's a weld for that rod.
No weld. It is just straight rod.
It was heated in the middle.
No, see, the hanger, no, when I opened it, there was a bend there. That's all.
Sir. Okay, no, okay. That's it.
Fantastic, yeah. He deserves a chocolate. Tell me again. You didn't do. Oh, you were there, right? Anish, okay. So, what did you do? Bent it back and forth. Back and forth. Why? Because the first time when you bent it, it didn't break. Correct? And therefore, what did you do? You straightened it, and then again you bent it, straightened it, again you bent it. You did that, no? Which means I'm applying a load that is repeated load. Right? How come it didn't break at the... See, I applied the same force with my hand, correct? Bending force. It should have broken in the first instant itself. Why did I have to bring it back and then again bend it? Bring it back, again bend it. Yeah.
There would probably be micro cracks which you couldn't see, and bending it and that motion would open them up bigger until it broke. Deformations in the crystal structure until it failed at some point.
Okay. So, the understanding has to do with... Yeah. Before we go to understanding, this back and forth was responsible for breaking. Correct? Which means that a repeated loading is more dangerous to a material compared to just one stroke. What did you do with the sheet? You pulled it, that's all. You didn't pull it and then bring it back, pull it and bring it back. Correct? Here, you had to do it, and each time you did it, what happened? What happened? Each time you did it.
The center weakened.
Okay. Do you have... Oh, okay. I had given a small sheet. Yeah. Okay. So, any sheet of paper that somebody can help me with? Any sheet of paper? You want to go and quickly take one of them? Distribute to others? That's also fine. Yeah, give it to them. Others, just pick up some sheet. Pick up some sheet, go. One of you can go in the group, get it. Pranav, can you
Yes, sir.
tear it into
Four.
four pieces?
Yes.
Four pieces. This will be 8. Quickly do it. That is yesterday's card is perfectly all right. Even if it is torn into 2 pieces, no problem. You can give one group member with that.
How big, sir?
Hmm?
How big?
Just small piece, like what she has. A small piece is enough. Once you have it, Oh, she's still doing it. You have some more pieces, no?
Yes, sir.
I'll take these.
Yes, sir.
Okay.
1 minute, sir. I'll just try.
Give me this also.
Yes, sir. I'll now get
4 pieces. You have enough?
Yes, sir. We have enough, sir.
You have enough?
Extra.
Okay.
Sir, yeah, extra. Sir.
Okay. So you use the table. Exactly what I asked you to do yesterday, but wait. While one side of the group will watch, the other side will tear the sheet into 2 nice equal halves. Right? One side will watch, observe. Remember, observe is a very important exercise. So decide among yourself who will observe, who will be tearing. When they tear, when they do that, observe carefully. Carefully. Yeah? Observe. Seriously. You're observing. Yeah, nice 2 pieces. Nice 2 halves. Make sure it is nice 2 halves. Once one side of the group has already halved it, the other side will start, and the side which was tearing will observe now. Go ahead. Ah, there you go. Anish gets 1. You want to choose? I'll choose? No. Only 1. Ah, only 1 chocolate. All right. Done? Raise your hand if the group has done. Oh, okay. All right. Again, chocolate question. What did you observe? Oh my God, so many. Okay, so we'll go group by group, okay? So that group, what did you observe? They first bent it. Very good. They bent it. Good point. This group.
Sir, we creased it first and then.
You creased it, okay. You did bend back and forth, and then creased it also. Very good.
Same answer as that.
Yeah.
Sir, we took the paper.
You'll write in answer same answer as my neighbor.
So we took the fold. We folded it front and back, creased it, and we made a small tear, and on the line.
Small tear and you tear. Very good.
Sir. When we crease it on both sides, we decrease the structural integrity at that point.
You,
1 minute.
this guy, no. Again, one more professor is in the making.
And
Yeah.
then, so when we tore it, because that's the weakest point now, it'll tear at that point.
Very good.
They're very neat. Sir, chocolate.
Okay. No. Wait.
Oh, this is not the.
First is you just make a crease and you just pull it apart.
Ah.
And the
second is you just direct line.
Okay, so your observations were spot on.
The more number of times we bent it, the more we creased it, the neater it became.
Neater it became. Very good. And same. Absolutely good observations. F for fun, you had some fun looking at the other, tearing, etc., and then you observed it. Then comes understanding. Why was it that you did all this? Is the question, correct?
So the more tension the part of the paper is at, the easier it is to bend it and break it.
So the more
Okay.
deformations that
Okay, professor has to wait.
it shows that if multiple forces act on a specific point, that point weakens and makes it easier to bend.
Okay, so it weakens is what you're saying. All right.
Okay. So, sir, when we are bending it, we are actually creating a weak point, sir. Like as we saw in the
Weak point or weak
like a weak like line.
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 Okay.
Weak
So
line.
that we can easily tear it equally apart.
What did we do? What did we do to the sheet at that creased line?
So
A
can you
small
repeat
crack.
What did we do? Wait,
Small
wait.
crack.
I need one word answer.
Small crack.
Only one word answer. What did we do?
Press it. Press it.
Tear it.
One word, sir.
Weaken is
A
very
lot of
general.
pressure.
Okay, crease it. Crease it, press it.
Applied force, layer by layer. Huh?
We applied a large force in a small area.
You applied a large force. What happened to that material at that time?
It got deformed.
Means, tell me a little bit more.
Stress strain.
You already know about the tearing, right? So tell me about
It
more.
reduced that's
The
one.
strength of the
Yeah.
tensile strength of the material, so making it easy to tear and crack and rip.
Almost there, almost there.
We reduced the
You don't know what is shear.
So stress and strain, sir. We do.
I don't know stress and strain. Make it simple. Always make it simple. Density of that material. How did you reduce? Correct. That's what they are also saying. But how did you reduce? What made it reduce?
Young's modulus.
Multiple times at the same point.
You wanted to say something.
Particles away by
Vibhav, yeah.
created a gap through which we push the particles away.
Yeah, but what is it that you did? She's right. Applied large force at a point, correct?
Crack.
Yeah.
Weak point. Crack.
Huh?
Crack. Weak point.
What does large force do to the material?
Deform it.
It weakens the structural integrity.
When you bend it itself, you are deforming it.
It weakens the structural integrity.
Structural
Structural integrity is
Make it simple here. What happens when
We are making the plane to be weak, then the rest of the
you
pressure,
Pressure, thrust.
press, modulus.
what happened to the material?
It got weak.
Yeah.
It became weak.
Became weak. Damage the particle. Very good. Yeah, but not yet. Wait. The question I have is, she is right, he is right. And I don't know about micro, etc. I'm just observing. Okay, I'm trying to understand from that point of view.
Fracture.
When I apply large force, what happens to the material?
It becomes.
See, I give a very difficult exam to you. What happens to you?
You crack.
You dash in the exam. Fail in the exam. It fails to have a function of being together. Correct? And what is the quantity is another thing that I have to ask. Correct? You remember that parameter? Right? Yeah. What is that quantity? Is it large force or large?
Load.
Huh?
Load.
Or large?
Stress.
Large?
Stress and
What is stress? I don't know stress here.
force per area.
Yeah. So if it is large force per unit area, I knew from the previous activity that the material will fail. All right, that's one thing. What's the difference between pressure and stress?
So
Pressure is external,
perpendicular.
stress is internal restoring force.
Very good, wonderful. Or in other words, when I conduct the exam, I am putting pressure on you and you get stressed. Is clear? Right? So, it is the stress that it experiences beyond
Elastic limit.
a threshold. I don't know. See, that's what you people always have something hiding which is to be removed. Have a blank slate when you observe. All right. This micro atom, I don't know all those right now. When I do a research, it's a completely different story, right? So all I could see is that was like what he said, weaken or damage or fail, because at that point there was more force per unit area than what it was, and therefore we damaged that particular line. Now because it is weak,
It tore.
why should it tear because it is weak?
It became the fracture. It became the fracture point.
It requires a less force. The
Like, sir,
threshold to break lowered.
The force when it's weak,
As-
that
as
means
the
it's kind of
material
damaged. That's why
As
we can
compared to the
easily
rest
tear
of the
it.
plane, it has a
The
lesser.
strength became less.
It requires a less force to tear it apart.
The
Yeah.
strength became
So
less.
when you tore it, when you observe that, when you tore it, you pulled. Correct? When you pulled, all of them should be experiencing the same force per unit area. Correct? Since it is weak, it will give way faster than the other, and therefore this happens. Lot of explanations we had to give in order to make sure that this is the case, right? Now what happened with Sharan and
Vani.
Dhani? You're right. A couple of you found out that I had already made a small cut and made sure that they won. Ani won because he did this back and forth all the time. When Pranav was doing some talk, this, that, and all those, so he was struggling. Correct? That's why I asked you to find out whether you can help Pranav break it.
Yes, sir. Very great.
Finally, you did it.
Yes.
Yeah. All right. So I'll reserve the chocolate for the next exercise. After understanding comes noticing. Can you give me some ideas of noticing?
So bridges.
Yeah. So where do you notice? Yeah, go ahead.
So when we build bridges or construct buildings, then
Hmm.
they fail after at some point only. That's because
Under
force
a
has been
lot.
applied over a long time. They don't fail immediately after building them.
Yeah. So what you're saying is there is a
It
fatigue
builds
that
up.
is happening.
Yes.
Okay. All right. What else?
When a extra tall building
Hmm.
after a permit is built, the ground experiences a lot of stress, and after some years, it would collapse because of that stress.
Okay. I don't know buckling yet.
Bending of the bridges.
Bending.
columns of bridges happens
Ah.
because a large amount of force is applied on a
Very small lane.
Which area here? I don't know.
Bridge.
Which is that point?
middle point.
Sir, when we make balls for making chapati from the dough, we
Ah.
apply force again and again to the sides.
You mean kneading?
No,
That's called kneading.
Balls form பண்ணும்போது திருப்பி திருப்பி எடுப்போம் சார் அதான் சார்
That is called kneading. Kneading the chapati dough. This guy has not gone to kitchen too much.
chef sir
You are just looking at.
chef sir
Okay, then you should know that word called kneading. K-N-E-A-D-I-N-G.
Not the atta mixing.
Ah.
Talking about making balls from that. Removing
சார் சப்பாத்தி தைக்கிறோம்னா அந்த ball
Removing the balls.
like from the dough.
So you will cut and remove it. What? You will twist and do it. Oh, okay. All right.
Not sure, but tectonic plates, there
Mm.
Like even now they are still rubbing, but we don't feel anything because it's not reached a certain point yet. But once it does, I think like an earthquake or something will happen.
That's different. I'll come to it. Just ask that question a little later. Okay.
Knife making, so we put the pressure again and again.
Okay.
And then it becomes melted.
Actually, reverse happens. I'll come to it again. The two of you will ask again.
So in a technique of cutting glass, they will
Yeah, they will make a cut and then they will break it. That's perfectly all right. But how is it connected to this?
So when making swords, for example, they make sure it's both flexible and rigid at the same time by adding carbon to the mix.
Yeah, but you're now shifting the ball somewhere else.
Stress fractures.
Where do you notice such a thing?
Stress fractures in runners when they like usually it's the tibia when they run a lot, right? Then sometimes over time a fracture can develop on your bone.
Where?
bone.
Tibia.
Where in tibia?
Yeah, at one of these places.
Why?
Because there is a
that's when
ligament
you're
there.
running.
Why?
You're continuously impacting that point. It loses its structural integrity.
Okay.
So the joint is not, I mean, it's not a single straight thing.
Okay.
Connection. Not about this. Another example.
Yeah, go ahead with any example.
So cracks on a cricket bat, a handle comes out of a bat over a period of time. A small crack develops, and as this load is continuously put.
Okay. So bat is made in a particular way.
Yeah, I'm talking about the two-piece bats.
Two-piece bats.
Yeah.
Yeah.
The ones that are used for gully cricket, for example.
Yeah, all the bats are made with more elements, by the way. Okay.
Yeah,
But
so
what is it that you want to tell us?
there's a crack on the handle, and once this load is put it again and again, the crack expands, and after a period of time, it disintegrates.
Okay. Any other that?
Our bones,
Huh?
our bones,
Our bones.
they are yes like slightly brittle, but not too brittle.
Okay.
Because if it was too brittle, it's like break our bones.
Yeah, I don't know what is brittle yet. No.
Like if you like apply a small amount of force, it'll just like snap into two. It's not like it's not very brittle, but it is.
Yeah, I don't know what is brittle yet. We'll come to that.
Okay,
So make it simple. Make it simple. Where do I notice? That's all.
when we fall down, we have a really bad fall.
When you fall down, what happens to you?
The force gets impacted on the bone. Like if you smash it against
At a particular point.
yeah, at a particular point.
Okay.
That point would develop like a hairline.
Why?
Because the bone's strength,
Why?
the bone can withstand so much force.
Relate to what you did, ma. What did you do?
A large force is experienced on a small point.
Exactly. So the point here is there are certain regions where
Sir, one question.
it experiences
Large
large force per unit area.
This time that we're also talking about force over time, right? So it's a large force.
Yeah, over time or repetition of load. We'll come to that. But when you creased and tore,
So scissors, sir, might be one example. Like when you have scissors, you apply the.
we'll come to scissors later. Scissors is a different story altogether.
So in the leather watches will be repeatedly by the watch, it's the same hole. The pale structure develops here.
Why?
Because we keep bending it like this.
again a large force for a long time. A
Yeah,
small
so that's a
force for
repeated
long
loading.
time.
Very good. Very good.
Pieces on shoes, like
Ah.
like those.
The sole breakout.
So-
is due to that.
So good. So what you're now saying is there is large force per unit area at certain regions over and over, and that causes weakening of the material.
That's a very good answer.
Sir, in the Tetra Pak, we poke the straw through the hole.
The
Correct.
straw is in this way so that the area is minimized and more pressure is applied.
Very good. Very good. So there is a weak line through which it tears off. Very good. Ah. Yeah.
Axis would be the large amount of force is concentrated on
One single thing. Correct. Very good. Yeah. What else? What else? And you have to do it over and over at the same point, right? And you're doing that so that you want to fatigue it. Okay.
Bone are stronger than other
Yeah, but what do more forces do?
Like causes more degeneration, so it is built strong.
Okay.
So the mechanism by which the nail cutter works, when you just press it like this, that's leverage.
Yeah, again, sharp edge. Okay.
When you're cutting a tree, if you repeatedly use an axe and get to just the
That's what
center
he
of
is
the
saying.
tree, you can just push it over.
Yeah, so you're repeatedly applying the force per unit area at the same point over and over. You're weakening just like you did the creasing. Correct. Very good.
When a waterfall, water from a waterfall falls down, and the rocks underneath get
Fantastic. She noticed a fantastic phenomenon where when it falls, that part alone becomes more deep. Correct. Wonderful.
Even those
We'll warm up to chocolates later, but yeah.
even those dismantling laborers on like at construction sites. So they are like just hitting hammers or something randomly, not randomly, but like at a particular point on the particular iron rods or something like that. Again,
Yeah, but make it simple now. What would you be doing with the hammer? That would be useful, no? What would you use hammer for?
To break
No, just notice, observe what you do. Huh? Huh? You have the nail, right?
apply a large force again and
Large
a
force
small area.
again and again, right? It has to do with what is called fatigue, right? You fatigue the material, right? It applies to us also. We get stressed because my parents always ask me to study, study, study. You're not studying. You study, study. So I get fatigued. Huh? He's looking at the teacher and saying, oh, okay. Anything else you want to? I am totally bold in terms of the responses I'm getting. I'm hoping that this will continue till we finish this session. So basically what happens is, no material is made of crystals that are perfect in nature. There will always be something which is a defect. It is not the other parts of the material, it is a defect. Just like your crease, that matters a lot, right? The more perfect the crystal is, the better its strength is. Okay. Now, how do two molecules or atoms
Combine.
stay together in a material?
Internuclear.
Bond, correct? Bond. Now, supposing I tell you the bond strength is this much, usually what unit do you think people will use? Joules. Joules is energy, no? Yeah.
So, but bond is actually
Bond strength, you say, no?
store energy, right? So bonds store energy. So we describe bond strength in terms of energy.
Is it so? You describe bond strength in terms of energy? Yeah. What is energy then?
Ability to do work.
Like for
Ability
example,
to do work.
the bond
With how much we can apply something.
Okay, so let's think of it like this. Let's just focus on two atoms. All right? They are bonded together. Right? I don't know what is that bonded together. So I'm going to now describe. Bear with me, but my throat is sort of hurting. They are bonded together, meaning they are together because of a particular phenomenon called bonding. Correct? This bonding is something when I pull these two atoms apart, they refuse to stretch. Correct? And the greater the force that is necessary to stretch, the greater is the strength. Correct? Right? Yes or no?
Yes.
And if I take think of it like this. Each of the edges has an atom, another atom at the other edge. If it is a single atom, single pair of atoms, I have one atom here, one atom here, and when I pull it, I'll get an idea of the bonding strength, right? And if I have a lot of them like this put together, and then I do this exercise, what I'm now talking about is a lot of atoms experiencing this force, right? That is when I now shift from a force to force per unit area, all right? So, there is a link between bond strength and strength of the material. Supposing I have a crystal like that, just take one of them very nicely arranged. I'll give you the magnets so that you can understand what I'm talking about. And when you want to stretch it, you need to apply a force per unit area that yeah. What do you mean by fail there? Tear means what?
Bond breaks. Bond breaks. Break bond. Break bond.
The atoms will go apart, right? That apart is the fracture or the crack or the cut that you know of, all right? Now, given this, usually the bond strength, if I may use that word, bond strength is typically in the units of force per
Unit area.
very good. If it is force per unit area, and if I want to find out the strength of such a material that I'm showing over there, usually when you test it, let's say this is aluminum, this consists of grains of crystal that you are able to see there, correct? The strength of this aluminum is typically 1/10 of the bond strength. 1/10 of the bond strength, which means it has the scope of becoming stronger and stronger and stronger. Okay, how we do it, etc., we'll discuss more. Clear? So the link between strength and bond strength, typically, ideally, it should exhibit bond strength, but it doesn't because there are defects in it. These defects play a huge role in terms of bringing the strength down to 1/10 of the bond strength. Is this clear? Okay. Let's understand three important characteristics of materials. There are many. Who is a strong guy here? A strong guy. Somebody come, volunteer somebody. Volunteer somebody. One of you come. Okay. What do you know about him? Very strong, right? Huh? What do you mean by that? What do you mean by that? So if he breaks it, huh?
He can apply a large force on anything.
Okay. Tell me one sport where the strength matters. Weightlifting. Okay. Now, if what's your name? Kautik. If Kautik is able to lift a weight that is more than any one of you, he is the strongest here. Correct? What does it mean when I say strength of Kaushik? தொண்டையில கிச்சு wait. Okay. So Kautik. Let me get some water. Kautik now wants to be stronger than what he is today. What should he do?
Eat more protein.
Go to the gym. He should exercise his muscles.
More protein and
Do muscles have the same strength per small portion of muscle that you take? Yes?
has the
Same strength. And therefore, if Kautik has to increase his strength, what should he do? Thank you.
He has to increase the amount of work it is.
Okay. No, increase the amount of muscle. When he increases the amount of muscle, what is he essentially doing?
So can you repeat?
And while exercising, like making micro cracks in his muscles.
Yeah, don't go too deep here. Unnecessary. Very simple question. Very simple questions. We'll just look at only one aspect of it. Let's say muscle. He has to grow his muscle. But by growing his muscles, he is going to get stronger, is what you're saying, correct?
Yes, sir.
Why is it that growing muscle will make him stronger? Huh?
So you apply more force.
He can not apply. He can,
Do more work or
Exert.
do more
Huh?
Exert a lot more force.
yeah, or in other words,
withstand.
withstand. Wonderful. So he can withstand. So its strength is an ability to withstand large force per unit area. So let's say between Kautik and Shiva, who will win? Definitely Shiva. Politics, huh? No. Hey, anyway, I was a weightlifter in college. Hey, no, come on. Now I understand what is strength. Are there any other characteristics? Give me a. Are there any other characteristics that you should know about a material called Kautik? What is the strength of Kautik? We have finished, right? He can lift 30 kgs easily. Yes, Kautik?
I don't
Say
know.
yes.
Yes.
Okay.
What is his limit? What is his limit? He cannot lift.
Beyond 30, what will happen?
He will fall.
He will buckle. Yeah. He will just, yeah.
After lifting it,
What changes? Okay.
his fail point, fracture point.
Yeah. So we already talked about strength. What else do you think concerns Kautik?
What he is made of.
Bones and
He is made of, just like what you are made of, he is made of all those tissues. Yeah. All of us know it. What else would you want to know? Correct. That is what is called strength. No elastic limit.
So how conductive he is. Sir.
Conductive.
All of you. Yeah, folks. All of you are making a mistake. You don't know what is elastic. I've conducted research for 40 years. Take it from me, elastic is not what you think.
Swayam Prabha. Digital India. Educated India.